Imagine, if you will, your child comes to you late at night with a tummy ache. What do? Typical remedy: rub on it, love on it, tell them it was something that they probably ate, check, make sure they're good to go, get them tucked back into bed. It happens again the next morning, the next evening. Tummy ache, tummy ache, tummy ache. You tried, your remedies, some teas, try to soothe the stomach, make sure that they didn't get any type of food poisoning, and retrace steps. This continues to happen for a few days until you're concerned enough it's time to go to the doctor. You run by your local clinic, the doctor does his typical checks, says likely just a tummy ache, could be a tummy bug, gives some medicine, and the problem should improve. Over the weekend, the problem doesn't improve. A fever develops and a cough, and obviously your child has some type of sickness. You work on the fever, you do your typical child care treatment, and you're taking really good care of your child. But the condition continues to get worse and worse and worse and worse to the point you decide it's time to go to the emergency room. You go to the emergency room, the doctors there run tons and tons of tests, and come to find out your child is diagnosed with Legionnaire's disease. What is Legionnaire's disease? It's basically a very severe case of pneumonia. Now, you would think maybe this was, a story from the 1800s. What are you talking about? Because Legionnaire's disease was basically gone when we had sanitation, we had hygiene, and all of these things. So why did it show back up here? Well, doctors inform you that it's not just your child that has it, but a lot of people in the town have it. Now, this sadly isn't some fantasy. This is reality. And this is 2017, and this is Flint, Michigan. There's two things we need to learn from Flint. Number one is that you have a system where people or humans are involved in getting something safe and clean to your home, that there should be checks and balances. Now, there's EPA, there's the federal government, there's the state, there's all kinds of reports. But anytime you have humans involved in that, there is a potential for mistakes, for problems, for neglect, for corruption. I'm not here to throw anybody underneath the bus and say that every water association isn't run perfectly. Even if so, humans can make mistakes, and that can lead to unsafe drinking water coming into your home. Dirty water, unsatisfactory, too much chlorine, so on and so forth. We understand conditions and such as that, where the water can still be safe, but isn't satisfactory, isn't what we want. The second thing we need to learn from Flint is that the term drinking water is really a mistake, because the water that comes from your tap isn't just for drinking. In fact, Legionnaire's disease is an airborne bacteria, meaning the only way it's communicated is by breathing it in to your lungs and being infected that way, not by drinking it. So you say, how did these people get sick? They got sick due to it being aerosoled. Now that could be from turning on the tap, and the spritz around the water could be what they inhaled, drinking from the tap sideways with it, spritzing that way and inhaling it. More than likely, it was from showers, because showers create steam then is breathed directly into the lungs. So the thing we need to learn from Flint is that when you're trying to make safe water for your home, a point of use type filter for your drinking water, though good, isn't the full thing needed. In fact, one 10-minute shower is the same as drinking an 8 fluid ounce glass of water. The skin, our skin, is the largest organ of our body, and in a shower, our pores expand and allow bacteria and things inside of our body that way. So when we're filtering water and we're talking about safety for the home, we need to filter not just the water that we're going to be drinking, but all the water coming into the home. In 2017, 2018, I was a young business owner just starting out, and I had all these high goals and high aspirations for finding the perfect water filter. Yeah, I know, I kind of set my goals kind of high, but I had some criteria that I was looking for. I was looking for a water filter that was economical, that wouldn't require tons of maintenance and expensive upkeep, and that could be installed in such a way it wasn't invasive into the home. So I embarked upon a journey trying different water filters. And of course, we were going to use whole house water filtration instead of just point of use because we wanted to filter every drop of water coming to your home. And we needed something that would last a long amount of time. So that kind of got out those cheaper whole house water filtration where you change the little cartridge out on it, every month, every 3 months, whatever, because it's both expensive. And if it's something routine like that, you're just not going to do it. And then life happens, you get busy, and you might as well throw the thing away. In fact, studies have shown that bacteria can actually grow inside of those after they've been installed over a certain period of time, and they've trapped so many different minerals and things inside of them, they actually start to grow bacteria. So that was not an avenue that we wanted to go down. That point put us into the filters where you have ones that'll treat, 10 million gallons of water, and you change them out after that 10 million gallons of water. We didn't like this avenue, but what we did is we tried a few. And what we learned is that the 10 million gallons just wasn't truthful for here in North Mississippi because there's different water qualities, and they were stopping up, and they were actually stopping to be effective at around the 3 to 5 million gallon range instead of the 10. And what we didn't want to do is install this into someone's home and then have to change it out. They've got a big investment. We didn't want to have to keep doing this even every three, years or so. That doesn't make sense. So we knew we needed something that could be replenished or, backflushed. And that's where the key term came in for backflushing. We actually got the idea from a pool filter. A pool filter uses sand in a large container and pumps the water through the sand. The sand traps everything. When the sand stops up, they reverse the flow, it spits out the bad stuff, and you've got your sand filter rejuvenated or backflushed and ready to go. So we started to play with this idea. How would this work? The problem is that the three components of any good water filter um, that we were looking to use was activated charcoal, another product or application for killing bacteria, and screens. So the screens are no problem. That makes sense. Big screen, smaller screen, small, 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 all the way down to zero point 0.3 micron. Meaning that when it goes this way, it gets filtered more and more. When we reverse the flow, it can come off those screens and get flushed out of the filter. This part was easy. The charcoal, the activated charcoal, because it's a carbon-based product, is the perfect filter media. It takes out 99.9% of chlorine. It takes out your calcium, your magnesium, all the white stuff around your faucets. This was golden. The problem is that charcoal is naturally soft. Now, I'm not talking Kingsford charcoal that you put in your grill. I wish the filters would be a lot cheaper then. We're actually talking about a really hardened form of charcoal. And this charcoal is baked at a very high temperature. What it does is it takes the porousness away from natural charcoal. Charcoal is very porous, it's very holy, which means that there's tons of surface area for water to interact with. That would break off and dissolve, and that's what most cheap filters use today. We were looking at a product that actually was baked at a high temperature and would glassify. So it would take away those pores, which means instead of having a porous material, we've got a hard material like rock, and we got to make it way bigger. So we knew we'd be looking at a big style filter. We found the numbers, we did the test, and we found what size we needed in order to treat, a certain size home, certain flow rate, and be able to backflush it. Then we took that size and we doubled it, just because we wanted to make sure that the claims that we were making to customers were true on how often that they would have to backflush or rejuvenate this filter. Now, we don't have the dissolving happening because the charcoal is hardened, and the charcoal can last a really long time, 30, 40, 50 years in most applications. We've got the perfect screens. We've got this media now that we can backflush, but we were left with one more thing. We needed to kill bacteria. How do you kill bacteria inside of a closed filter? We basically had three different avenues for killing bacteria. Number one's chlorine, which that would make sense. We're taking chlorine out, we're putting it back in. So that's no. The next would be to use UV. UV light naturally kills bacteria when it comes in contact and is used in water filtration all over. The problem is that this would require a power source, it would cost money to run it, and you'd have to change bulbs. Three things we didn't want to do. The last is an amazing product that we found is being used in a lot larger commercial application and now more and more whole house water filtration systems. It's a product called KDF. What is KDF? It's a bunch of elements. Again, our filters have no chemicals. So these are naturally occurring elements. And as water goes through these elements, finely ground particles, it actually creates static shock. Very much so like taking a balloon and rubbing it on the side of your hair and then going and touching your best friend and laughing. That static shock, instead of annoying your best friend, kills bacteria. The heat generated, the electric shock, kills 99.9% of all bacteria. The NSF, national standard, has a rating for how many pounds you have to put of KDF in order to be able to say it kills bacteria. Obviously, for a certain flow rate and water rate. We took that, maximized the flow rate to any house would be using, and then we multiplied it times 3. This allows us to get enough KDF 85 where you can confidently know that all the bacteria that's coming into your home is being killed in that KDF 85 and making that drinking water safe. So now we needed to address the where we're going to put it thing. Most of the time you see these big filters are installed in an attic, they're installed in the garage, but that's invasive. Drilling holes in the side of walls, trenching across people's yards, not to mention if the power goes out, your filter, your water in your filter is going to freeze and it's going to bust. You're going to lose your investment and you're going to flood your home. Not cool. So what did we devise? We needed a way to bury the filter. So we had to change the housing. We changed the housing to use a very thick fiberglass resin to be the housing for the filter. Some filter put them on their side. That way you don't have to dig a very deep hole. But we found that to not be effective because the settling that would happen on the bottom of the filter. So we devised a way of actually making the vertical filter, the way that all modern filters are designed to be vertical, just a really deep hole. And so that's what we do. We bring this extra thick fiberglass tank in that's got our filter media built into it, and we dig a very deep, wide hole, and the filter literally is buried right past your water meter. And every drop of water that comes through that meter is filtered through the filter. Now, whole house water filtration is great, but what if you have, a faucet and that faucet is tied in before the filter? A lot of people think this is a good idea. Oh, I don't have to worry about that being filtered and pay for that filtered water. Dogs play in sprinklers. Kids play in sprinklers, and you get right back to that whole aerosol effect. Why risk it? Why not filter every drop of water that comes onto your home? And that's what we can do with this filter that hit all 3 of the best things. It's back flushable, it lasts a really long time, it's economical, and it's installed in such a way that doesn't have to worry about the weather. It's out of the way. It blends in. We put a meter cover over it, just like your water meter, and it blends in perfectly. It's a win-win, win-win-win for everybody. So next steps. Listen, we decided that we wanted people to be able to access this information and know what was in their water. So we actually are offering a free water test. We'll come out, we'll test your water. We're going to tell you what's going on inside of that water and make sure that our filter is a good match. We're not going to sell you something that doesn't work and doesn't solve all your problems. So we're going to walk you through that process. Once we've selected and found the filter that's right for you, you approve the quote, we're going to install that filter. After the filter is installed, we're going to test that water again for you, and we're going to show you the before and after. Listen, water filters aren't only there just to make your life safer. It's also there to make your life easier. And when I say these filters are going to pay for themselves, they're going to more than pay for themselves. First question that's usually asked is, can I take the filter with me when I leave? Absolutely not. We bury it. It's in there. It's not going anywhere. But every realtor and every home inspector we talk to says that the increased value on the home more than makes up for the cost of the investment. Homeowners love water filters, and knowing that one like this is already installed in the home is going to increase the value of the home more than the cost of the filter anyway. So take that savings with you, take that money with you, and install another water filter in your new home, and you're really just spreading safe water all over as you're doing that. The other thing that we are oftenly asked about is what all the water filter does for the home. Every water using appliance in the home is affected by this water filter. You're going to notice cleaner dishes. You're going to notice less water spots in the shower and soap scum because that's just residue left when the water dries. It's what's in the water. Well, if there's nothing in the water, then there's nothing there to spot. There's also your water heaters are going to have longer life with less maintenance. You're going to notice your clothes are going to not smell like chlorine and all those other chemicals that are put inside them. You're going to notice cleaner clothes. You're going to use less pool chemicals if you've got a pool because it's cleaner water. It's easier to treat and keep clean. There's so many avenues. Anything that has to do with water is going to be safe and it's going to give you peace of mind that it's extending the life of everything that's using this water. Most of the time appliances fail is they fail due to bad water. And so that's why we're taking that aspect out and you can use that cost savings all the way through. We're really excited about the product that we're offering. We really feel like we've made that trifecta of that perfect water filter and we really look forward to giving you that free water sample to show you what's in your water, what's it doing, and what we can do and what we can make it. Let us know how we can help. If there's any more questions you have, trust us, we're full of knowledge on this. We've done the research, we've built these filters, and we want to make sure you, the homeowner, are knowledgeable about what's going on and you can prevent any issues down the road.